and some simple explanations about process management. Process management is a part of operating system responsible for creating, scheduling, executing, and terminating processes. It makes sure every running program gets the resources it needs, like CPU time, memory, and input-output devices without stepping on other processes' toes. So as the process management goes, it has process creation, the one that you made, and the scheduling, execution, then killing the process or termination. Next is process creation and termination. So you start the process or an application that's called a new process, and after the process, it will be terminated. The OS creates a new process with a unique process ID, what you call PID, and a process control block, PCB. It terminates a process when it finishes its job or crashes. For process creation, the OS creates a new process whenever a program needs to run. A unique process ID, PID, is assigned to identify the process. The OS allocates memory and loads the program's code and data. A process control block is created to store important process information. The process is then placed in the ready queue for CPU scheduling. Processes can be created by the OS, users, or other processes. While process termination, process ends. A process ends when it finishes the execution or is stopped by system or user. The OS removes the process from active execution and frees all used resources. The system updates the process table and records the process exit status. The termination will be normal or abnormal. The OS deletes the process PCB to keep resources and the system efficient. CPU scheduling is how the operating system selects which process from the ready queue should run next. It ensures efficient CPU use, fairness among processes, reduced waiting time, and smooth multitasking. It determines which process in the ready queue runs next. It ensures fair sharing of CPU time among processes, helps maximize CPU utilization, minimize waiting and response time, supports smooth multitasking and user experience, prevents conflicts and slowdowns when multiple processes runs at once. So CPU scheduling, there are many there are many processes. This is the CPU and it decides what process will be taken first. Process synchronization. It ensures multiple processes can safely share resources. It prevents conflicts when processes access or change the same data. It avoids problems like data inconsistency and race conditions. It controls access to critical sections, part of codes that use shared data. It keeps data safe and the system running smoothly. Helps processes work together properly in multitasking environments. The two processes are being synchronized by which the shared resources. Process synchronization coordinates the execution of processes that share resources to avoid conflict. Inter-process communication or IPC allows different processes to share data and messages, helps processes work together and coordinate tasks, used when processes run independently but need to communicate, ensure data is transferred safely and efficiently, works both within the same computer and across networked systems, important for multitasking and distributed systems. Deadlock handling deals with situations where processes are stuck, waiting for each other. Happens when processes hold resources while requesting others already in use. Creates a circular way, stopping on involved processes. Prevention or avoidance reduce chances of deadlock. Detection and recovery finds and fix deadlocks when they occur. Ensures system stability and keeps resources available. Prevents processes from being blocked indefinitely. As for my summary, process management is how an operating system like Windows, Mac OS, or Android controls all the program running on a computer. A process is just a program that concurrently running like when you open Chrome, Spotify, or a game. Process management is the OS jobs, starting, running, organizing, and ending programs so your computers work smooth without freezing.